Then in the first class we discussed, I'll quickly go through the slides. You don't need to write anything, just have a look. I'm just doing a quick revision in your unit 1 theory paper, first lesson. Okay, what is the first lesson? It's hardware and software. You're almost done. Right, majority of this lesson, sub lessons of this first unit in all levels. Then these are the 6 lessons we got. I already explained last week the structure of the paper and the topics we need to cover. Right. Today, last class we didn't do any practicals. Today we'll start kind of an introduction. Okay. Right. In hardware and software lesson, we basically start with types of computers based on size. Supercomputers, mainframe computers, mini computers, and microcomputers. Right. I'll quickly go through because these things are familiar and we already discussed last week. And under microcomputers means all personal computers, right? Any personal computer, including smartwatch. Right. When you look at the technology, some computers deals only with analog signals. We call them analog computers. Some computers deal with only digital signals, right? Digital computers. All our personal computers are digital microcomputers. But especially in health sector, they use hybrid computers. That means they are process analog and digital both signals. Then embedded computers you can see on pictures, right? Some kind of modern equipment especially designed for one purpose, right? There is a CPU inside and also there's a program running. When you look at automatic washing machines, there's a program running. Okay, then we learn game consoles, easy. Input devices you already learned in all levels. Any device which communicate with CPU and the device is sending some instructions or commands or data to CPU, that is input device. Basically you are inputting data into the computer. Then remember all the scanners comes under input device, right? All the scanners. When you say scanners, flatbed scanners, barcode readers, OMR. OMR mean optical mark recognition, OCR optical character recognitions, MICR magnetic in character reader. All the scanners comes under input device. Then we divide scanners into 2 parts, document scanners and biometric scanners. Some scanners are identify humans uniquely. For example, a fingerprint scan, iris scan, face recognition, voice recognition, right? Then types of sensors. Remember all the type of sensors. Any sensor comes under input device. Why? Those sensors detect kind of an environmental change. Okay, any environmental change can be detected by sensors. It can be temperature, humidity, light, okay, rain sensors, proximity, right, motion, right. And output devices, let me remember, any output device is outputting one of 3 things, right? Output device can output a soft copy. Soft copy means the stuff that you can see on the screen. It can be a document, Word document you're viewing on the screen. It's a soft copy. Then we use a monitor or screen. Monitor or the display unit is an output device. Projector, output device. Right. Or soft copy, or it can be hard copy. Hard copy means when think about a Word document. If you're viewing on the screen, it's a soft copy. When you take a printout, it will become a hard copy. Then printer is an output device. Any printer. Okay. Or it can be sound. Soft copy, hard copy, or sound. Those are the three stuff we can output using output devices. Then we learn about printer types. Okay. Some of them are impact printers, some printers are non-impact printers. And we discuss all the printers, right? Then monitors, there are three types of monitors: CRT, LCD, LED. Okay. Uh, right, computer ports. We discussed all the ports last week. What is the first one, Lama? USB. Second one, what's the name? PS2. PS2 ports. Okay. The name is PS2. Don't
Okay.
think 2 is something which is not belongs to the name. It belongs to the name of this port. Okay. PS2. Right. We can connect type of mouse and keyboard. Right. We can't connect USB mouse and keyboard to this port. Remember, if you want to connect keyboard and mouse to this port, you have to buy a specific keyboard and mouse designed to plug into this port. This is VGA, HDMI, serial, parallel, audio port. And remember the devices we can connect. Okay, monitors and all the display units. These two, monitors, projectors, smart TVs, anything. Right. Right. Before we go to the today's lesson, in Unit 1, is storage devices. When you're discussing storage devices, you have to draw a diagram. When you say computer storage, right? I'll discuss only on secondary storage first, or sometimes we call auxiliary storage. Right, write down this topic and don't write this one. You might tell me computer memory or any device which can remember something or hold some data can be divided into two parts. What are they? Right, we can divide all the storage units in different ways based on different factors. Right, sometimes we can divide it like primary. Don't write it. Primary memory and secondary memory or secondary storage. Okay, sometimes we divide volatile memory and non-volatile memory. What is volatile, non-volatile mean? The storage or memory is going to delete when we switching off the device or shutting down the computer or stop electricity supply. Whatever the volatile memory, it will keep the memory inside the device until we supply the electricity. How we are going to stop? We have to shut down the computer, switch off. Or it's a desktop computer, sudden power cut can affect everything you're gonna you were doing at that time is gone. That is why you need to save when you're creating something. Because if something happens while you are creating something, you can't recover it. Okay, right. The other way of dividing all the devices is volatile memories. Example is RAM. Okay, remember, random access memory is a volatile memory, right? In your computer, random access memory is a volatile memory. Why? It remembers something until your computer is switched on. Okay, all the currently running programs are going to store in RAM. That is why when you playing a game, right? Think about a high performing game, then you need high capacity of RAM to play that game. Why is that? While am I for computer games we need a huge RAM, because when that game is running, it's a huge program, right? It need to manage your inputs, graphics. It needs lots of processing power, and it need to remember something. All the moves you're gonna take, right? Everything need to remember, because that software or that program is running at that time. It needs to do a lot of stuff. Therefore, they need to remember temporary inside the RAM. Right? It's a temporary memory. Volatile mean temporary. Then when you stop playing or when you close the program, everything inside the RAM according to that program is gone. Delete. But when you're playing a game, you can save your progress, right? Then it will save inside the hard disk, not in the RAM. When you play the game next time, start with the place you stop, right? Because it's saved in hard disk. Right. Now, I'm not talking about volatile memories and non-volatile memories. I'm talking about secondary memories here. Okay, that means secondary storage only. The primary memory I will discuss later. Okay, right. Then secondary storage can be divided into three parts according to technology. You can remember. You already done it in all levels. According to technology, by looking at the technology of those secondary storage devices, we can divide into three parts. Okay. First, tell me why we call them secondary. Second, examples of secondary storage is your hard disk, CDs, DVDs, memory cards, SSD hard disk, floppy disk, magnetic tapes, all of them comes under secondary storage device. Then they are permanently stored something. That is, they are not primary memory. They are not volatile memory. All of them are non-volatile. Non-volatile means permanent. Once we saved something, it's there until you delete it. Okay. Think about hard disk. Once you saved something in your hard disk, it's not going to delete automatically. It will there until you delete it. Right. Then all of the devices we are going to categorize under secondary storage are permanent. They are permanent storage. But there are three technologies. That's what we are going to discuss. Okay. First one is magnetic. Tell me the other two. Lama, did you record in the class? Yes. Okay. Magnetic storage media. Write it down with me. You have to write down at least 3 devices, 3 magnetic storage media. Yes, optical, media, optical storage media. And solid state media. You can say solid state storages, optical storages. Just remember these 3 words: magnetic, optical, solid state. Right? Those are the 3 technologies. Then under magnetic storage media, what are the devices? Have you seen magnets? You did practicals in school, right? Using magnets. How many poles are there? 2 poles. NS can be changed, right? But only 2 poles. Then what is the technology we use to store data? And the other thing, Lamai, computer is going to store something. Let's say this is your hard disk, right? You are going to save an image, or you are going to type a letter from your keyboard, A, okay, or you are going to save an audio or video. Everything is going to store in hard disk, okay. Then Lamai, how all these data is going to store in hard disk? What is the format? In which format is going to store? By using binary format. That means ones and zeros. Any storage media, it doesn't matter, image, video, audio, or numbers or letters, going to convert into ones and zeros. Then all these storage medias, something like CDs, hard disk, memory cards, pen drive, all of them are storing data by using ones and zeros, right? If there is only language that computer can understand, or that the only 2 symbols we can use, every storage device is using a technology to represent 1 and 0. Got it? If we want, we can invent a new storage device with new technology. If you can find a technology to represent 1 and 0 separately, then you can use the technology to make a storage device. Then we use 3 technologies. One is by using electromagnetic field. Like magnet got 2 poles, electromagnetic fields got 2 states. By using those 2 states, we can represent 1 and 0. Our target is representing 1 and 0. Okay, this is one technology. Then by one device is magnetic hard disk. We normally call it HDD. Hard disk drive means magnetic hard disk drive. Okay, I will write magnetic. Write it down with me. Hard disk drive. Okay. Other one is floppy disk. Another example is magnetic tapes. Right. These are the three examples of magnetic storage media. All these devices uses kind of the same technology. By using magnetic field, they store data. Okay. Right. Then I'll discuss about hard disk drive after drawing this diagram. Okay. We'll show you a video as well. Then my optical storage media. Tell me three examples. Optical. Again, this technology, it's a different technology. Okay. But it uses ones and zeros. What is the technology? One example is CD. Then a CD or DVD, Blu-rays, got tracks. Tracks mean they got some kind of lines. We use these tracks to store data. Okay, there are lots of tracks, but you can't see it from your eye. Right. What I do is I'll take this small part of the track from a CD and I'll zoom in. Zoom in. I'm going to look at this small part. Okay. Then actually, when I look at this small track, it look like something like this. Okay. That means there are some pits and bumps. It's not like a smooth surface, right? There are some cracks. Then we use them to store data. Right? We create these pits and bumps according to binary pattern. That means when it receives a signal like 1 0 1 0 1 1 0 1 something like this, they represent it like this: 0 1 0 1 1 0 1, like this. Okay. Then who is going to create these tracks? Initially, when we're writing a CD or DVD, it uses a laser beam to create something like this surface. Again, when you reading it, we can read using a laser beam as well. Using a laser beam, we read the surfaces and read this binary pattern 1 0 1. That's the technology. Got it? You just need to understand. Okay, you don't need to write anything, but if you won't just write something under optical storage media, something like this, then you will remember something. Right. Then what are the examples of my CD? DVDs, and Blu-rays. Right, Blu-ray disc. Right. Who can tell me what's the difference between these three? What is the difference between CDs, DVDs, and Blu-rays? If they are using the same technology. Hello? Anyone? When you compare the capacity of these devices, CD, it's around 700 megabytes, MBs. DVD, it's around 4 GB. They're not exact value, they can change according to the brand and the type. But Blu-ray disc, there are different sizes. Let's say 16 GB and above, can go up to 150 or something. Then the capacity is increasing. How? What is the technology? Let's think this is a CD. DVD, something like this. That surfaces and bumps is tiny. Right, 10101001, something like this. Okay. DVD, Blu-ray, they got tiny surface. Something like this. Okay. They can read by laser beam. Right. Got the idea? Then what is the technology used in solid state? Solid state media. Remember, Lamai, this is the place where we differentiate these two technologies completely. That means, remember, Lamai, magnetic storage media and optical storage media both are moving when they're working. Right? There are some moving parts inside. CDs and DVDs are rotating. Hard disk drive, platters are rotating. Floppy disk rotating. Magnetic tapes rotating. Okay. And all magnetic storage media, optical storage media got moving parts. But solid state media, all solid state media, they don't have any moving parts inside. Nothing move. That's the biggest advantage. Example is pen drive. Memory cards, SD cards. Have you heard about SSD, hard disk, solid state drive? It's a hard disk. There are mainly two types of hard disk, two technologies. One is HDD. It comes under magnetic storage media. When you're buying a hard disk from a shop, you need to decide what kind of hard disk you are going to buy. Is it HDD or SSD? Which one is better? Hmm. Which hard disk is better? By looking at the access speed, SSD is much more better. Okay, why? Okay, I'll come to that point. Okay, wait. All these solid state media got lots of advantages, Laman. What are the advantages? Mainly the physical size. Right, physical size is small. Why? They don't have any moving parts. They made up with ICs, some kind of circuits. Okay, when you look at inside the pen drive or SD cards or SSD hard disk, it's got only circuits, nothing moves. Right. Let me just draw this table. You need to compare and contrast hard disk drive and solid state drive. Both of them are hard disk. Okay. Okay, what I am going to do, I'll show you how HDD works. Okay. Right. Just look at this video. It shows how the magnetic hard disk. Okay. Uh, at the beginning, it shows how magnetic hard disk works.
The hard drive has been the main storage device in computers for decades now. Do you ever wonder what's on the inside? Hard drives are sealed so that no dust can get inside. Once you take yours apart, it most likely will not work anymore. The platters is where the information is stored. Both the top and the bottom of each platter is used so it can store as much information as possible. The actuator arm is how it reads and writes information. They never actually touch the platters, but you need a microscope to actually see that. It moves so fast that the human eye will have trouble keeping up with it. The platters are split up into tracks, and each track is split up into sectors. When you read or write to the hard drive, the actuator arm must find the right track, and the platters must rotate so the right sector is underneath the arm. It only takes a few milliseconds for this to happen. This may seem fast, but compared to newer technologies, this is much slower. In recent years, the hard drive is being replaced by the SSD, also known as the solid-state drive. These have no moving parts on the inside, which means they are faster, smaller, and use less power. However, SSDs are still a lot more expensive than hard drives. How long before the hard drive is obsolete? Only time will tell.
Right, got the difference. Then HDD, inside HDD, there are lots of moving parts. Okay, there are some platters, and platters are rotating. There's a read-write head, it's moving. Okay, the place where the read-write head is fixed we call actuator. These are platters. Okay, platters are fixed into spindles. These are several names. Right, then SSD got no moving parts. Right, I'm telling this one again and again because there are some questions in past papers. Okay, they're asking why SSD cost more than HDD. Cost of SSD is high. HDD is cheaper. It's kind of a old technology. Okay, but still the amount of storage, the store capacity of HDD is higher than SSD. The devices in the market right now. In future, it will be different. Okay. Dilemma. Because SSD got no moving parts, there are several advantages. It's durable. Okay. than HDD. HDD is damaging, data is going to corrupt when it vibrate or when you drop the device, those kind of stuff. It's not durable. And this one is small, physically small. Therefore, we can use them in small devices like smartphones, tabs, the laptops. Because it's durable, it's more suitable for mobile devices. But when you drop a smartphone or something, data should not be damaged. Okay, for SSD, the more suitable storage medium. And the other main advantage, Lama, is one of the main important factor, which is access speed. What is access speed? Okay, access speed means how long it will take to take some data from SSD, okay, to CPU. How long it will take to read something in SSD compared to HDD, it will take less time. Because it takes less time to read something, we can say access speed is high because it's quickly accessed. Read something quickly compared to HDD. Okay, that's the main reason we use SSDs. If you want to make your device faster, actually the processing speed is not going to increase, but when you replacing HDD with SSD, you will feel that your computer is getting fast because it access data quickly. Right, those are the differences, right? I'll give you 3-4 minutes. Joshua, we can't say SSD can be used to store more data, right? Depends on the capacity of the hard disk, then we can decide. Normally, right now in the market, right, when you're buying a hard disk, HDD got more capacity than SSD. Okay, still the affordable SSDs comes with like 256 GB something, 512. But you can buy magnetic hard disk like 1 TB, 1 terabyte, 2 terabytes. 1 TB is how many GBs? Approximately 1000, exactly 1024. Okay. The thing is, Lama, in the exam, you should be able to write what you know. Right? Sometimes that's the biggest problem students have. They understand everything during the class, and they remember everything when you go to exam, but they don't know how to write it. Therefore, Lama, the strategy is to write the stuff you know. The other thing, do you know the forgotten curve? Raise your hand if you know anything about forgotten curve. This what did I explain last week in the last class?
Yes, sir.
Yes. Just listen carefully. The thing is, the amount of mm, the stuff you learning today, you won't be able to learn everything that I'm going to teach. That's the truth. By assuming Stuff you learn today is 100 stuff you have learned. Tell me how long it will take to drop into 50%. It will take only 2 hours. Okay, 2 to 3 hours. It will drop to 50% if you didn't revise. Revise කරේ නැත්නම් තමයි අඩු වෙන්නේ. Okay, මුකුත් නොකර ඉගෙන ගත්තට පස්සේ ඔහේ ඉන්නවා. පාඩම් කරන්නේ නැහැ, revise කරන්නේ නැහැ, මුකුත් කරන්නේ. Now after 1 week, it will drop between 20 to 30. Right, then you can draw the curve like this. The stuff you learn today is 100. After 1 week, it will be 20 to 30% if you didn't revise. This is why revision is important. What is the most important time period that you need to revise something? First 2 hours. After the class, within 3 hours. That is why we are doing quizzes. Okay, after every class, I'm trying my best to give a quiz regarding the stuff we learn. Right, today also I'm going to give you a quiz. The stuff we learned today from secondary storage devices. All the questions are based on secondary storage devices. Then you can revise. And stuff you learn through this quiz, it will revise it again before 2 to 3 hours. Then what happens? It will boost. If you can revise it in the middle of the week, it's much more better. Then at least after 1 week, you will end up with 50% or 60. Okay, this is not my curve. Okay, scientifically, scientists have proved that. And it's common for everyone, not for you, not for me, common for everyone. Right, now secondary storage devices are done. Okay, you should be able to compare and contrast, and you should have a proper knowledge of different three technologies. Right, now right, we'll come back to theory lesson. Today we are not going to do any practical, but I wanted to show there are some extensions you can install. I'll explain it later. It means maybe once you go to extensions, you can see some recommendations and all the stuff. The live server, which I recommend, is live server. Auto rename tags, fluent icons, they are better. Okay, right. I'll come to this point later. Don't worry about them. Then under this folder section, Lama, you have to create a folder somewhere in your computer and choose that folder. For example, in my desktop, I created HTML and there's a folder called AS. Inside that folder, there's AS24. This is a folder I created for your class. Right. Likewise, you have to create a folder and open that folder from here. Okay. And everything you're gonna create, you should be able to save in that folder. Then it will be organized. Okay. And by using this plus icon, you can create a new file in your selected folder. Okay. Right. What I'm going to do is I'm going to create a HTML file. Right. When I click this plus icon, new file, it will open small text box. What you need to do is just type the file name. Right, I'm gonna type first underscore HTML. Right, oh, I'm gonna say first page dot HTML. In this way, Visual Studio Code identify this is HTML file. Okay. Right, from next week onwards lamai we are going to start practicals. Just for today, but I want you to show the basic structure of the page. Okay, sometimes this basic code will automatically appear in your HTML page, or you can type it. Okay, are you familiar with your content, right? AI's content, I mean the topics you need to cover. Next week I'll explain a bit what are the lessons, what are the areas we are going to cover, and we need to do JavaScript. Is there anyone who knows JavaScript? I mean, have you learned JavaScript before? No. Do you know Java? Do you think Java and JavaScript same? I mean, Java, both of them are programming languages, but there's a difference. Okay, Java is purely a programming language we can use, kind of object-oriented programming language. But JavaScript is specifically designed for client-side scripting. That means only for websites. Okay, I'll explain when we doing this lesson. For now, just remember their difference. Okay, first we learn HTML basics. While we are learning HTML, we start learning CSS, right? Hypertext markup language, HTML, cascading style sheet, CSS. Right? HTML is the one we use to structure a web page. That means HTML is the one which actually create the web page. Every web page you're gonna see when you're browsing internet, definitely it has created with HTML. By using CSS, what we can do? We can combine CSS and HTML together. What CSS is doing? CSS වලින් මොකද කරන්න ළමයි? CSS වලින් පුළුවන් මේ හදන වෙබ් පේජ් එක වලට ලස්සන කරන්න. You can design, or you can make it more attractive. Right? That's why we call it cascading style sheet. Then we learn JavaScript. Once you create a website using HTML and CSS, you can do programming. You can program using JavaScript, but it's client side. I will tell you the difference between client side and server side. Okay.
Sir, I have a doubt. It's a doubt.
So, Disha?
I have a doubt.
Yes, tell me.
Now, sir, you said that CSS are used to make the website more attractive. Sir, can't we use HTML code itself to make it more attractive? For example, we can add images there's a HTML code called img. For example, to add a paragraph, we use attribute p. So those are used to make more attractive.
This is a difference. Okay. Think about, I'll open a web page and show you. Right, w3schools.com. This is a web, kind of a good websites to learn HTML, CSS, JavaScript, and other programming languages. Okay, this is a web page. This web page also created using HTML and CSS. But the thing is, you can see this website has something like it's kind of modern. When you move in the mouse, it will change the color in the background. Can you see this stuff? And these buttons, the links are changing the colors, and the fonts, there are different font colors and more structures, right? The background colors, borders, everything. These kind of fancy stuff can be used HTML, but the stuff you can see here, that means stuff you can see means this word JavaScript, these letters, definitely you need to include it using HTML. Okay, if there's an image, for example, there's an image here, there's an advertisement running here, right? This advertisement, and all of these things are links. It'll lead to another web page. You need to create those content using HTML. After create the content, or the stuff you can see actually on a web page, if you want to change how it looks, then use CSS. But you will feel when you doing a web page now, when you're creating a web page. Okay, what you can do using HTML, you can include everything. You can insert an image to a web page. Yes, you can. You can create a table. Yes, you can create a paragraph. Yes, headings. Yes, and you can create what else? Ordered, unordered, definition list. What else? You can create frames. Okay, these are the stuff we need to include into a web page. But think, if you want to draw a border around the image, the options available in HTML is very less, right? You need to border around this image, and that border should not be a normal border. It has some kind of design. Then we can't do it using HTML. We have to use CSS. Right? There's a table here. Okay, you have to add different colors for different cells, or the table border to make it look nicer. Then we can't use HTML. You have to use CSS. Got it? The relationship between HTML and CSS. You can't use CSS without having HTML. There should be elements created with HTML to use CSS. Okay, you can't replace HTML by CSS. Don't think we can't remove HTML code from a page and we can include CSS. No, that is not how it works. You already doing CSS to HTML elements you already created. HTML should be there. Clear, sure? You don't get it 100%. Once you create a web page, complete web page, you will get it by using CSS HTML both. We use the web page here, right? What is the name of the page? First, my page is first page.html. Okay, then we'll actually go to that folder. I'll show you that folder. Right, this is my desktop folder. There's HTML folder here. Once I go inside, there's an AS folder. This is AS 2024. And here's my actual web page which I've created by using Visual Studio Code. Got it? First page.html. It is HTML file. If you didn't save it like .html, it will look like a text file. It doesn't show your web browser icon. If you want to see it, you just double click it. When you double click, it will open this web page from your browser, your web browser. Right now, it doesn't show anything. Why? You didn't tell anything to show in your code. Right? My HTML code body section is empty. There's nothing. Right? That is the next thing you need to understand, Laman. I'm just going through the basic stuff, okay? Because once you missed any of these basic stuff, it will be very hard for you to continue this lesson. Everything you're gonna create inside this body section is going to display where on the web page. Right now, there's nothing. Okay, all these tag names and all the others are not going to display on a web page. Any tag name is not going to display. Remember that. Tag names are how to identify a tag name, a tag, by using these brackets, angle brackets. Anything inside this angle brackets is a tag name. It's a tag or element. Right? And then we got lots of tag names here: doc type, HTML, heading, meta, title. Then what is the difference between opening and closing tag? For example, HTML. This is the opening or closing tag. This is an opening tag. Why? If you want to close it, only different is slash. Okay, this is the opening tag. This is closing tag. That is why we are creating everything in between opening and closing tags. HTML. Okay. Slash is the only difference. Then does every HTML tag has a closing tag? Does it need to have a closing tag for every HTML tag? You can see a tag meta. Okay, it has a slash here. That means it doesn't mention a closing tag, but tags something like img, image. If you want to insert an image, you don't need to mention a closing tag. Just opening tag is enough. But almost 90% of HTML tags are going to close. Okay, not 90, 95%. When you take all HTML tags, 95% of HTML tag has its own closing tag. Something like HTML and HTML closing tag. Head opening tag, closing tag. Title opening tag, closing tag. Body opening tag, closing tag. Got it? Right. Then this is the basic structure, Lamai. This is the basic structure of a HTML page. You need to remember the order. Right. Doc type, I will explain what is doc type and everything later. Just remember HTML tag is a first must including tag to your HTML page. After HTML, you should open a heading tag. Before you close the heading tag, you should include a title at least. Title of this page is title. Okay. Then this is not a mandatory field. I'll explain every tag. Right. What is meta tag? What is this charset? UTF-8 means everything I will explain later. If you didn't include this part, it is also okay for now. Okay. Doc type also, it's okay if you remove it. Then you need to get familiarized with this Visual Studio Code lamai. Okay. මේක පොඩ්ඩක් ඔයගොල්ලෝ ක්ලික් කරලා බලන්න. එඩිට් වලට ගිහිල්ලා එඩිට් එකේ මොනවද තියෙන්නේ? ක්ලික් කර කර බලන්න. කැඩෙන්නේ නැහැ නේද? වැරදි දෙයක් ලැබුණා කියලා මුකුත් වෙන්නේ. ආයෙ uninstall කරලා install කරන්න තියෙන්නේ. ඒක හැම එකම ඔබ බලන්න. Just create folders. Just go to extensions. Don't worry about extensions right now. Right. And create files. Create more HTML files and go to folder and check whether you have created a file correctly. For example, I'm going to create a h1 tag. What is h1? H1 means like a heading tag. You can create a heading tag. For example, I'm going to create a heading called HTML. Then when I'm saving this one, it will display on the screen. I mean the output. As a heading. There's an additional bracket there. Let's see. Right. Okay. Then this is something like basic HTML. There's a heading here. That's it. Okay. Then what are the stuff you can do for this heading? You can make it center. If you want, you can make it more. You can increase the size of the font, and you can change the font color. You can make it bold and make it italic. Okay, underline. Then you can apply a background color. Great. There are a lot of stuff you can do. If you want more options, always you need to go for a CSS. The styles you can apply for something is limited by HTML, but when you go to CSS, there are more options, designing options. But we'll learn them later. Right. Then under secondary storage device, just remember these three technologies and the differences and examples of each type. Okay.
Kasun Sameera, shaping your future with the best ICT experience.